Friends, we know that the PLC sees an input voltage at the analog input terminals. It converts that to binary code, then gives us a number representative of the binary code. But how many bits and what numbers do we use? Well, in the software simulator, we can actually change the resolution. If we jump into the I/O manager, we can see if we click on our analog input, down here, the resolution is 12. This means that the PLC is using 12 bits to break up the 0 to 10 volt range into a number. Now, the best way to explain what's happening here is to show you. Let's play around with the resolution. Jump into the sim and crank the slider all the way up to the top. What does it go up to? 4095. Okay, what if we go and change the resolution of this input to 4? Press save, and back in the sim, the full range of numbers that we can use to represent 0 to 10 volts is 0 to 15. Now that's because if you remember, 4 bits in binary code can only give us 16 numbers, 0 to 15. And what do you think the range of numbers will be if we change the resolution to 16 bits? Let's do that. Okay, change it to 16. Alrighty. And save. And back in the sim. Okay, look at that. Bottom number is 0. And the top number is 65,535. And every number in between represents a small change in voltage at the input. See? Okay, and just quickly, this is obviously an unsigned integer. That's why it obviously goes up to 65,000 and not 32,000. Remember we learnt about signed and unsigned integers earlier in the course. Okay, now why do we care? Why are we messing around with this value? Well, say we had a process where, a chemical was being heated in a tank and there was a temperature sensor in the tank connected to the analog input on a PLC. Now, at many different temperatures, the chemical turns into different products. It could be that at 40 different temperatures, we can turn this chemical into 40 different things, like, one might be lipstick, one might be shampoo, one might be silicone, who knows, margarine, anything. You know what I mean? So if we needed to detect 40 different temperatures accurately, we're not going to use a 4-bit resolution which only gives us access to 16 points in the temperature scale, are we? No, we're not. We want to use more resolution to achieve greater accuracy, so we can really dial in on the exact values that we want to pinpoint in the range. Okay, now, don't stress too much if this is a bit confusing. It will make more sense after we do a few examples. It always does. So for now, change the resolution back to 12. And save your work, and I'll catch you in the next lesson, where we'll start using these things in a programming sense. Cheers. Alrighty friends, enough of me blubbering on about analog